Hi, in this assignment, we're working with the IRIS dataset, which is a dataset of 3 flower classes, and the features are their petal and sepal length and width in centimeter. We have 150 rows of samples here, and as mentioned, 4 features and 3 classes. And the classes are distributed evenly in the dataset so that we have 50 of each of the classes. And moving on, we draw this correlation table between features and targets to see how correlated they are. And we see that 3 out of 4 features are highly correlated with the targets, and the one remaining is relatively correlated. So in the previous assignments, we did a stratified sampling to make sure that the distribution of data in both the testing and the training sets are appropriate and they don't bias our findings and our model learning. And in this case, we want to separate a test size of 10% size of the whole data set, and we want the classes to be distributed evenly. So we will have 5 of each class in the final test set, which is 15 samples. And for the training section, we go through a few different algorithms, and for each of them, we train a default hyperparameter number first, and then we do a one-dimensional grid search to find the best hyperparameter based on a 5-fold cross-validation, and then we calculate the accuracy of that for the test set. So starting with the decision tree classifier, we had used the decision tree regressor before. And for the loss function or for the performance of that algorithm, we use root mean square error. But in this case, we use for accuracy a parameter that is basically the ratio of correct predictions to the ratio of the total predictions. And we also use one hyperparameter in each case to validate our model and to find the best accuracy. In case of a decision tree, the hyperparameter, for example, is the max depth of the tree. I'll briefly go over this first one and then the other complementary algorithms that we ran. For this one, we did a 5-fold cross-validation and a grid search to look at the different values of the tree depth from 1 to 10 to see which one is the best one. And we found that depth 2 is the best one that gives the accuracy of 1. So in order to make sure that this number is not an overfitted model, we ran the same model to predict the test set, and we got an accuracy of 1 for the test set as well, which shows that it's not overfitted. And we could actually guess from the number of classes that we need at least a depth of 2, because a decision tree divides each node into 2 branches and cannot capture the differences between more than 2 classes. And definitely we need more than depth of 1, at least a depth of 2, to be able to distinguish 3 classes. And yeah, here we looked at some predictions of the test set to visualize the results for ourselves. And then we get into the 5 other algorithms that we ran for this assignment. I'm not going to go into details of these, but I will just briefly summarize each of them. So the first one is a random forest, which is basically a number of decision trees. And we follow the same approach as we did for the first algorithm. We find the best hyperparameter value, and then we test it for the test set. Then we get to k nearest neighbor algorithm. And for this one, we also need to do scaling, because this is sensitive to scaling, and some other algorithms as well that we explain later. And we again follow the same approach. We do a 5-fold cross-validation grid search, and then we try the best hyperparameter value for the test set. Same for perceptron. However, the difference for perceptron was that it didn't give us a good accuracy, and we'll explain later why this was. And the other difference for perceptron was that it basically has a couple different hyperparameters. So we tried with both maximum iterations and error tolerance to see which one works best. When we started with maximum iteration, we realized that it gives us pretty much same accuracies and all go through the same number of iterations. So we decided to then keep the number of iterations constant and instead change the error tolerance. So we didn't get into perfect accuracy at the end, that you explain later what the reason is. Then we did a support vector machine. Again, also scaling. And we followed the same approach, which we will explain further in the end. And last but not least, we did an AdaBoost algorithm, which is a combination of different weak classifiers. And in this case, we chose a decision tree classifier. And we followed the same approach. So in order to make a comparison between all the different algorithms that we chose here, the 6 that are listed on the left, we first looked into whether they were linear or not. And perceptron is a linear classifier. And it is actually the reason why it didn't give us as high of an accuracy as the other algorithms, because the iris dataset classes are not separable in a linear way. So perceptron is not a good choice for this. We then looked into the algorithms in terms of being multi-class or binary. And for the binary ones, we also looked into whether they're one versus rest or one versus one, which I'm not going to go into the details of this, but basically binary classifiers work in a way that they separate data into two groups because they're binary. And for that, they either compare one sample with another sample or one sample with the rest of the sample. And I also talked about the scaling, why it's important for these three algorithms, because they're distance-based. So even though all our features are in the same unit, they're all in centimeters, but they have different ranges. And the one with the largest range might dominate and bias our results. And then here are a list of hyperparameters for the algorithms. For decision tree, it's the depth, the maximum depth. For random forest, it's the number of trees. For k-nearest neighbor, it's the number of neighbors. For perceptron, we eventually chose error tolerance. For SVM, it was the regularization parameter or C-value. And for AdaBoost, again, number of estimators or trees. And these are the number of desired hyperparameter values that we found, and their accuracies, which is 1 for all cases except for perceptron that I explained why. And the 5 other algorithms, we're not really able to compare them in this context because our data set is a pretty much simple data set and clean and small. So we're not really able to distinguish differences of different algorithms in this case. But if it was a larger or more complex data set, we could compare them in terms of their robustness or their computational cost. So that's it. Thank you for listening.